Okay, the last part of this lesson is that we need to do a proof, getting our feet wet so we can do it later in another unit. Prove that a line perpendicular to one of two parallel lines is also perpendicular to another. So we are going to fancily prove that if CD is perpendicular to RS, then AB is also perpendicular to RS because of the fact that they're parallel. So here's what we're going to do. When you do a proof, you always start with the given. You start with the given, you start with the given. Okay, so given RS is perpendicular to CD, given segment RS is perpendicular to segment CD, why is the reason? It is given to us, handed, silver platter, there you go. Okay, now usually when we write down a given, we want to go as far as we can with that given. I know two lines are perpendicular. Well, there's a conclusion that goes with that. If two lines are perpendicular, then they form a right angle or 90-degree angle. Some of you are listening. I love it. Okay, so after we said they're perpendicular, then we said, hey, I now know the measure of angle 1. I now can state that it's 90 degrees. Now I have to back it up. You don't just say things without backing it up. So the measure of angle 1 is 90 degrees. What is the reason why? Definition of perpendicular. That's it. Just the definition of perpendicular. Look it up. Two lines are perpendicular if they form a right angle. Okay, so cool. Now it's saying, okay, you went as far as you can with that given. Now go to your next given. So, okay, I'll go to my next given because they already gave me a hint that that's where I need to go next. Segment AB is parallel to segment CD. We're not trying to prove they're parallel. That was given to us. Now that we know they're parallel, we're going to use the corresponding angles theorem because it told us to. What would be our statement if we use the corresponding angles theorem? What would we want to say? Good, but you can use the 1 and the 2. That's what's beautiful about it. I added those to make your life easier. The measure of angle 1 is equal to the measure of angle 2. How do we know they're equal? Because of this theorem. Well, wait a minute. If angle 1 is 90 and it's equal to angle 2, then angle 2 is... So what I'm going to do here is I'm going to substitute. Instead of the angle 1, I'm going to use substitution. What is 1 equal? What is it? It's 90. So I'm going to substitute 90 in for where I had the measure of angle 1. Why am I allowed to do that? Because of substitution. Oh my goodness, we're already on the last step. How do you end a proof? You start with the given and you end with the proof. You start with the given and you end with the proof. Segment RS is perpendicular to segment AB. And the reason, you don't put prove. Prove is not a reason. The reason, well, let's look at it. I just said that AB is perpendicular to RS. Why am I allowed to say that? Well, look at what we just said. Good job, you got it. We just said angle 2 is 90, and now we're saying they're perpendicular, and it's the same reason as in number 2. Definitions don't really have converses, but if they did, it'd be like the converse of the because you're going the opposite way of how the definition's written, but you don't put that. Definition of perpendicular. Very good. Over, done.